can't jump. Physics proves that you'll have too high of an acceleration to survive it. I'm gonna jump!
Using our givens, Batman has an initial velocity of 0 with the acceleration of gravity. We found that since Batman is jumping 3 floors, it would be approximately 9.6 meters. We then used the fourth equation to solve for the final velocity, getting 13.17 meters per second. Using the final velocity we got, this becomes the initial velocity of Batman hitting the car. We then estimated the indent Batman made on the car to be 0.4 meters. Using the fourth equation again, we manipulated it to find acceleration. Using these givens, we got an acceleration of 234.6, when the lethal speed is 6 Gs, which is equal to 58.86 meters per second, which is a lot slower than the speed Batman was traveling, therefore he'd die.
Very poor choice of words.
We estimated the approximate angle the roof is to be at 45 degrees. We then used sine and cosine to find the approximate initial velocity of the x and y axis to be 39 meters per second. We timed the slide to be 10.9 seconds. We then manipulated the first equation to solve for the final velocity of y, getting 55.15 meters per second. We took this and solved for the VIY and VIX using sine and cosine. The final velocities that we got now became the initial velocities. We then used the first equation to solve for the final velocity of the x and the y. These became our resultants, and used the Pythagorean theorem to solve for the final velocity of Batman and Rachel. Then we used the fourth equation to solve for their acceleration, which was 22,674 meters per second squared, which is a speed they couldn't survive. These 2 eggs represent Batman and Rachel falling off the building onto the car.
You know what else we could do? You know how my car...
Was that a bazooka? I didn't sign up for this.
The force the gun is taking to shoot the bullet should be the same as the force applied back on the clown. We solved for the acceleration that he would be moving back at. We found the force it takes to shoot a bazooka bullet to be 160 newtons. We then divided by the combined mass of the clown and the bazooka and solved for acceleration. We found that the clown should be moving back at 1.73 meters per second squared, when actually he doesn't move back at all. His final velocity after the bazooka was fired was found using the fourth equation, and we got 2.3 meters per second. This is the FPD of the clown and bazooka, and the forces acting on each of them. Our next scene shows what it should have looked like.
Use the bazooka! I'm gonna jump! Right up, jump! I gotta jump! Don't do it!
Look at the dent Alyssa left, where in the movie there seemed to be barely a dent. Oh, and Alyssa died.